In the first video of this multi-video tutorial series about the basics of FSX, I showed you around the outside of the stock Cessna 172 and pointed out all of the control surfaces on the aircraft. In this video, we'll be going inside the cockpit for a comprehensive look at the instrument panel and what everything does. My name is Michael, and this is the Sky's the Limit Aviation Channel. Hey everybody, we are back at KLZU in the cockpit of the stock Cessna 172 in FSX, and in this video we're going to get familiar with the layout of the cockpit panel gauges and what they do. We'll start from the left-hand side of the panel and work our way over to the right and finish with the bottom of the panel as you see it here. The first thing we're going to do before we get started is turn on the battery master switch and the avionics master and provide power to the aircraft. Now that we have power to the aircraft, let's go ahead and get started with the upper leftmost gauge on the flight panel, which is going to be the aircraft's clock, which is also called a chronometer. It is an FAA-approved time indicator and is required in the cockpit of all IFR-certified aircraft. Pilots use a clock during flight to time maneuvers and for navigational purposes. The clock is usually mounted near the flight instrument group, often near the turn coordinator. It indicates hours, minutes, and seconds. Also, at the top of the clock, you'll see the outside air temperature gauge, which in this case shows 55 degrees Fahrenheit. The next gauge is the fuel tank indicator. This simply shows the amount of fuel in both of the tanks of the Cessna 172. Next to it, we have the EGT and fuel flow gauge. These monitor the exhaust gas temperature of the engine and allows the pilot to set the optimal fuel and air mixture for the aircraft's altitude and power settings. The fuel flow gauge shows the amount of fuel burned in gallons per hour by the aircraft's engine. In the lower left of the gauge cluster, we have the oil temperature and pressure gauge. This monitors the pressure and temperature of the aircraft engine's oil. To the right of the oil temperature and pressure gauge is the vacuum and ammeter gauge. Some of the instruments in the cockpit operate off of a vacuum. Looking at the left-hand side of the gauge, the green band indicates the required amount of pressure provided by the engine vacuum that is needed for the instruments to optimally operate. The ammeter on the right-hand side of the gauge simply measures the amount of current in amps flowing through the electrical system of the aircraft. Starting in the middle of the panel and in the upper left, we have the airspeed indicator, or ASI. The airspeed gauge is a flight instrument that indicates the airspeed of the aircraft in kilometers per hour, knots, or miles per hour. The ASI measures the pressure differential between the static pressure from the static port located on the outside fuselage of the aircraft and total pressure from the pitot tubes. This difference in pressure is registered with the ASI pointer on the face of the instrument and gives you your airspeed. To the right of the airspeed indicator, we have the attitude indicator. Formerly known as the gyro horizon or artificial horizon, this is a flight instrument that informs the pilot of the aircraft orientation relative to the Earth's horizon and gives an immediate indication of the smallest orientation change. The heart of the operation of an attitude indicator is the gyroscope, which you can hear subtly in the background. Inside an aircraft, the gyro remains oriented upright while the aircraft pitches and rolls. To the right of the attitude indicator is the altimeter. An altimeter, or altitude meter, is an instrument used to measure the altitude of an object above a fixed level. Pressure altimeters are found in most aircraft today, but other types of altimeters include sonic, radar, and laser altimeters. Using a pressure altimeter, altitude can be determined based on the measurement of atmospheric pressure. The greater the altitude, the lower the pressure. The two gauges stacked on top of one another to the right of the altimeter are the VOR indicators. Very high-frequency omni-range stations are a type of short-range radio navigation system for aircraft. enabling them with a receiving unit to determine their position and stay on course by receiving radio signals transmitted by a network of fixed ground radio beacons. They use frequencies in the very high frequency, or VHF band, from 108.0 to 117.95 MHz. Developed in the United States beginning in 1937 and deployed by 1946, VOR navigation became the standard of navigation in the world, used by both commercial and general aviation until supplemented by satellite navigation systems such as GPS in the early 21st century. In the second row of the middle gauge cluster, we have the turn indicator. The turn indicator, also known as the turn and bank indicator, provides information relating to the angle of the bank and coordination of the aircraft. Sitting next to it is the heading indicator, also known as the directional gyro or direction indicator. It is a flight instrument used in an aircraft to inform the pilot of the aircraft's heading. Next to the heading indicator, we have the vertical speed indicator, or VSI. This shows the climb or descent rate of an aircraft in hundreds or thousands of feet per minute. It uses the aircraft pitot static system to measure the rate of pressure changes in the outside air. Below the vertical speed indicator, we have the tachometer. Essentially, a tachometer is a motor speed gauge that is driven by the speed of its exhaust valve. In simplistic terms, tachometers are dials with a needle that point to the current speed in revolutions per minute. To the right of the tachometer is the ADF gauge and its associated panel. The automatic direction finder is used to navigate to NBDs, or non-directional beacons. NDBs transmit in the AM radio bandwidth and are picked up by the ADF when their frequency is programmed into its panel. Today, ADF-based navigation is a dying technology, replaced by VORs and made nearly obsolete by GPS satellite navigation. The magnetic compass is the only instrument in the aircraft by which a pilot determines the direction of flight. Magnets in the compass cause it to align with the magnetic North Pole. It is nearly always fitted on top of the visor that shades the instrument panel, or is hung from the top of the windshield frame of the aircraft in order to keep it as far away from electrical gear as possible. The compass shows the 4 cardinal headings shown as north, east, south, and west. Numbers appear every 30 degrees. Long vertical marks occur in 10-degree increments, with intervening short marks at 5-degree points. On the right-hand side of the cockpit, we come to the communications panel. The comm panel allows the pilot to communicate with air traffic control and other aircraft. It is usually located on the instrument panel of the aircraft and contains a radio transceiver that allows the pilot to transmit and receive messages on a specific frequency. Localizer, ILS, and VOR frequencies can be programmed into the NAV 1 and 2 sections of the comm panel as well. Below the comm panel is the DME panel. DME, or distance measuring equipment, is a seldom used technology used in navigation to determine the distance between VORs and in present day has been replaced by GPS navigation. When flying in the flight simulator environment, you will likely not ever use the DME. Below the DME is the transponder. A transponder is an electronic device that produces a response when it receives a radio frequency interrogation. All aircraft have transponders to assist in identifying them on air traffic control radar. Collision avoidance systems have been developed to use transponder transmissions as a means of detecting aircraft at risk of colliding with each other. Below the transponder, we have the autopilot panel. An autopilot is a system used to control the path of an aircraft without requiring constant manual control by a human operator. Autopilots do not replace humans. Instead, the autopilot assists the operator's control of the aircraft, allowing the pilot to focus on broader aspects of operations, for example, monitoring trajectories, weather, and other onboard systems. The autopilot largely maintains the altitude, heading, and speed of the aircraft while in flight. Finally, at the very bottom of the cockpit panel, let's have a look at the switches down there and describe what they all do. On the far left is the engine start switch and magnetos. After engine start, a magneto check is generally performed During the run-up, prior to takeoff, both the left and right magnetos are checked and a slight drop in engine RPM occurs when switching between the two. An RPM drop indicates normal operation of the magnetos. Next to the engine start switch, we have the master, battery, and alternator switches. To its right, we have the fuel pump, outside lights, and the pitot heat. Next to it is the avionics master switch, which provides power to all of the instruments and gauges in the cockpit. The panel light switch turns on and adjusts the panel lighting. Below that is the alternate static air source. It is a backup system that provides static air pressure to flight instruments in the event that the primary static air source becomes inoperative due to blockage or mechanical failure. To the right of that is the throttle. The throttle adjusts the engine power for taxi and flight operations. To the right of the throttle is the mixture lever. This adjusts the mixture of fuel and air going to the engine to optimize its operation during flight. Next to the throttle and mixture levers, we have the flap lever, the pitch trim wheel, and the fuel cutoff. The flap lever is used to operate the flaps to configure them for takeoff and landing. The trim pitch wheel adjusts the trim tabs on the trailing edge of the elevators to move the nose of the aircraft in up or down position, and the fuel cutoff handle is used during maintenance or emergencies to shut fuel flow off from the engine immediately. Finally, on the bottom right-hand side of the lower panel, we have the fuel selection switch. This allows the pilot to use fuel from the left or right tank separately or both at the same time. And with that, this is going to conclude this comprehensive but basic tour of the cockpit and instrument panel of the stock Cessna 172 for FSX. In the next video, we're going to take you through the checklists for the Cessna 172, and we'll perform those checklists from before engine start all the way up to the before takeoff checklist. I hope you enjoyed this informative video. Please be sure to hit that like button, leave me a comment in the comments section, and please support the channel by subscribing and make sure that you're receiving notifications for new videos that I'm working on or notifications when I do my weekly live streams. This is Michael with the Sky's Limit Aviation channel, wishing you clear skies and smooth flying. Bye-bye for now.